This workflow section looks at accurately matching surfaces to scan data, imported as either section lines or a mesh model. So we want to be able to create surfaces directly onto the scan data, and use the tools we've already learned to accurately match a center line, and then directly control the CV layout. But the key thing is to match the scanned shape. So I'll show you tools for fitting that new surface to the scanned mesh to get close to the scanned data. And we need to be able to measure any deviation. So this deviation color map, for example, shows when we're within tolerance in green, and it lets us work interactively to get closer to the scanned data. And we use a color map again with the curvature shader, and applying this to the mesh helps to identify the main feature lines. And we can start to extract these as curve data using the blend curves, which just snap directly onto the mesh. I'll show you a few tools that we use to help work with large data sets, and one of those is the mesh subset here on the mesh palette. And that allows me to trace around a portion of the mesh and select it and extract it as a separate piece, so that I can isolate parts of the data on the screen. And because a side window has particular technical requirements, I'll show you an option on the Revolve tool that lets us work directly on the scanned data to create a technically correct shape and a revolve axis for creating our glass surfaces. And with all of these techniques we can use the cross-section tools, and I'll show you how to measure the deviation in detail on any of those sections. And then we'll take a look at the Reference Manager, which allows us to work efficiently with very large and complex imported CAD data, so that we maintain the interactive speed on the screen and keep our file sizes manageable. And then finally we'll look at how we can organize imported section data using the Sort Scans tool, so that we can isolate the data that we want to work with. So this section will give you an overview of the methods used in reverse engineering to create high-quality NURB surfaces from scan data.